Then we have force. Force is mass times acceleration. Force is mass times acceleration. What is mass? Mass is kilogram. This is m. And acceleration is what? Acceleration is L over what? Over t squared. Acceleration is L over t squared. So mass times acceleration is ml over t squared. So if I'm writing the unit, it's going to be kilogram meter per second squared. Or if you like, you can write with this notation. It's the same thing. However, because of the fact that Newton did a lot of work under what now? Force. To honor him, his name was used now to replace what? This unit. So instead of us writing kilogram meter per second squared, we now write what? Newton as the unit of force, or just N as the unit of what now? Of force. So that is for force. And mind you, in examination, they could ask you, which of the following is the unit of force? They will use Newton. They will use what? Kilogram meter per second squared. So in case you see this, also know that this is what? A unit of force. Alright? Then we have pressure. What is pressure? Pressure is what? Is force over area. Force over area. Remember, sorry. No, that's going to be too far. Force over area. We already said that force is what? Kilogram meter per. Force was ml over what? Over t squared. Right? So if this is force, and then area is what? Area is L squared. Area has to be at the bottom. If I put L squared at the bottom, one of the L will cancel the remaining one. One of the L will cancel the one on top. So L will cancel L. So at the end of the day, I'll get M over what? L t squared. I'll have one L at the bottom. So if I'm going to write the unit of what? Of pressure, it's going to be what? Take note. I said force under dimensioning, we said is what? ml over what? T squared. Right? So if I now put area, force over area, area is L squared. L squared is here. L squared means L times L. So one of the L will be cancelled by the L on top. Right? So eventually I'm going to get what? M remaining on top. At the bottom I have L and what? T squared at the bottom. So what does this tell you? It tells you that what? The unit of force from here. Sorry. The unit of force from here can be said to be what? Kilogram per meter per second squared. The unit of pressure, kilogram per meter per second squared. Kilogram per meter per second squared. But because of the fact that Pascal also did a whole lot on pressure, to honor him, they said that what? The unit of force, of pressure should be what now? Pascal. Pascal. The unit of pressure should be what now? Pascal. PA. This is the unit of what? Of pressure. And we can remember that what? We said that the unit of force is Newton, right? And the unit of area is what? Meter squared. So I can also have what now? Newton over what? Meter squared. Newton per meter squared. All of these are units of force. Newton per meter squared, Pascal, kilogram per meter per second squared. All these values, all of them are units for what now? For pressure. Anyone you see in examination is what? Is acceptable. In fact, for pressure, we have so many different combinations, so many units, different types for pressure. When we do pressure as a topic, I will explain all of those. Finally, I want to, let me just do for energy. Energy and work, they have the same unit. Energy and work. Because they what now? It's force times distance. Sorry. Force times what? Distance. Force times what? Distance. We give you what? Force times distance. What do we say force is? Force is what? kilogram. Let me not take it so far. So the force is Newton, right? And then distance is meters. Distance from length. From length you get distance. So I can say that this is what? Newton times what? Meters. So give me what now? Newton meter. That's force. Newton meter. However, if I'm going from the fundamental, we have said that force is what? Force is kilogram meter per second squared. So if I multiply with distance, it's going to be what? Kilogram meter squared per second squared. This is correct. This is also correct. However, because of the fact that Joule has to be honored too for the work that he did, the unit of work and energy is said to be joules. Just J, joules. So this will represent this or what now, or this. Then finally, last but not the least, I'll talk about power, and I'll stop here. For power, power is giving us work over time. Work over time. The rate at which what now work is done is what? Is power. The rate at which work is transferred is power. So let's say that work is what? Is joules, and time is what? Is seconds. So work is going to be what? Joules per second. I know we can go about from the kilometers, blah, 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 and all of that, but I just want to stop here, joules per second. However, just like the other people, watts also did a lot of work on that power. So to honor him, the unit of power is what now? Is watt. But you can have all the others in examination and then just understand how you're going to go about it. I will show you one more thing, and then the class is going to be over. Alright? Okay, this is just a summary of the first six. I want you to do the rest by yourself. I just summarized the first six for you. I give you so many others, or rather a few others. You do them by yourself. There's pressure, there's power, there's work, there's all the others. You do them by yourself. This is a summary for them. This one's on this side, they're called dimensions. These are dimensioning. These ones are the dimensions and all of that. Is that right? Thank you.